Now, in a database, tables are not the only things we have. We have views, we have stored procedures, we have stored functions. We're going to look at that in part 3 of the course. But today we're going to focus on tables and views. We have seen how to work with existing databases, but we have not looked at how to create our own database and how to modify databases and how to insert record and run queries against our own new database. Before we start, let's assume a scenario. Let's say that we want to create an authentication app, maybe for a school. Let's say we have an app for a school and we want to create authentication and an authorization system. Now, when we say authentication, we want to make sure that when people are logged in, their identity is known by the system. And when they want to access different functionalities of the system, they need to have an authorization. We want to use role-based access. We want roles to define the authentication system, and we want permissions to define the authorization system. So let's say in this hypothetical database that we want to create, we want to store information, and this information will store in tables. And we want these tables to hold different information about the users, their roles, their permissions. When we talk about roles, let's use a school, for instance. Let's just use any secondary school, for example. There are administrative staff, there are teachers, and there are students. So let's say we have one role called admin, and under admin, we have the principal, we have the secretaries, we have all non-teaching staff. We have the teacher role, which is going to be assigned to a homeroom or a class or a subject. And then we have students, which belong to a class. We want to create this database so that we use something we call foreign keys to keep the integrity of the data so that all related information are linked. And we do not want to put information in different tables more than once. So if the information exists on the student table, we don't want it to exist in the admin table. We want to use a foreign key to make reference to those information. So let's say every non-academic staff is assigned to the admin role in this hypothetical scenario. So we have admin, we have teacher, and we have student. And every non-academic staff belongs to the admin. Every teaching staff belongs to the teacher, and every student belongs to the student. Within the admin, we have different permissions, different functionalities. Let's say, for instance, a principal can record appraisals for teachers. A principal can approve results before the students can see it on their pages. A teacher can record attendance of students in the class, or can mark scripts or grade scripts, and students can submit assignments and can view results. These are different permissions that are specific to each of these roles. So your assignment 3 asks you to do something similar, and so at the end of this lesson, you should be able to go on with your assignment 3 properly. So the permissions we want to use is, for the admin, we want to have a record appraisal permission, we want to have an approved results permission. In real world situation, it's going to be different, but we're just creating a scenario to build a database from. The teacher role will say we want to have a permission for mark attendance, grade script. And in the student role, we want to have the submit assignments and view results permission. So let's use these 2 permissions for each of the roles. So now you can see that in each of these hypothetical scenarios, every permission is linked to a role. And so we need to use a foreign key to link this. We are going to look at this shortly. But before we do that, let's look at all of the moving parts that we need to work with. There is something we call storage engine. And the storage engine determines the structure and the features of a table, and it manages how data is stored, retrieved, and manipulated within each table. Now, in MySQL, the default storage engine is InnoDB storage engine. But MySQL supports different types of storage engines, and if you want to see which storage engine your installation supports, you can run this query. I think it's select engine. Then select engine So everything we select is usually from the information schema. So every time you have an installation of MySQL, you always get this information schema there. And the information schema is just a set of read-only views that provides information about all of the tables and the views and columns and procedures in the database. So we're going to select engine, select support. We select these columns from the information schema table. We'll select this from information schema dot engines. So we're selecting from the information schema database, and we're selecting this from the information from the engines table, or we can just select that database and don't have to put this here. Okay, and we're on order by engine. So with this query, we should be able to see all of the storage engines that our installation supports. So we have the archive, it supports this. ARIA, Black Hole, CSV, InnoDB, which is the default, like I said earlier. Memory, MyISAM. MyISAM used to be the default before, I think before version 5.5 or so. And the reason we'll not use MyISAM is it doesn't support foreign keys and transactions as much as InnoDB, which is what we want to do to keep to something we call an ACID property. So you can see what it supports, and you can see what storage engine is your default storage engine. So our default is InnoDB. That is what we want. That's what we want to keep using. Okay. So I just talked about the ACID property, ACID. When you want to create your database, your tables, insert record in your database, you have to think of this word ACID. The A here is for atomicity, and what it means is that when you have a transaction, like you're inserting query, you are doing something with the data, you're changing something about the data in the table. Each statement in that transaction, that is, if you want to read, write, update, or delete data, is treated as a single unit. It has to be treated as a single unit for it to achieve atomicity. C is for consistency, and consistency ensures that transactions only make changes to tables in predefined and predictable ways. You can't do something now and the result will be different from when you do the same thing the next time. If you have that, your query or whatever you're doing is not consistent. Consistency has to be predefined and has to be predictable. Isolation. When we talk about isolation, it's like you have an application and you have multiple users reading and writing from the same table all at once. Now with isolation, the transactions ensure that the concurrent transactions don't interfere with or affect one another. If one person's interaction affects the other person, it does not achieve isolation, which means the database is not keeping to these properties. And then we have durability for D. And durability just ensures that changes to your data made by successfully executing transactions will be saved even in the event of a system failure. So every time you are designing your database, you're inserting records, you're writing your query, always think of ACID. Make sure, ask yourself, does it keep to these properties? And if yes, if it keeps to these properties, then it then means that you are doing the correct thing. We have something, apart from the storage engine, we have something we call the character set. And the character set is a set of symbols and encodings and collation, which is a set of rules for comparing characters in a character set. Collation is the set of rules for comparing characters in a character set. To understand this more, just think about we having different languages, and sometimes within one language you have different dialects. When we write this language or we write out things in different languages, you will see that the spelling, some of them have diacritical marks and all of that. This is where character sets and encodings come in. Depending on what kind of data you're collecting, what language you're writing your system in, what language you're serving, maybe you're writing a system and it's only going to serve the German-speaking population or the French-speaking population, you will take note of what character set and what encoding you will use. Now, because the most liberal of them all for multilingual applications is UTF-8, most of the time what you see people use is UTF-8. So UTF-8 is the best choice of character set for multilingual applications. Now, in MySQL, the default is UTF-8. I think it's MB4. We can also check this. You want to see what character sets and what collations your system supports. We can do that. But first of all, it's always confusing to understand the difference between character set and collation. And if you want to know what this is, it's just simply by thinking about it this way. You have, we say character set is the set of symbols and encodings, and the collation is a set of rules for comparing the characters in the character set. So, for instance, we say we have A and B, two letters A and B, and we assign A is equal to 0, and we say B is equal to 1. So, when we say A is equal to 0, it now means that 0 is the encoding for A, and then B is equal to 1, which means that 1 is the encoding for Y. Now, the combination of the X and or the A and B together is called the character set. So we look at the encodings to compare the two values. So you want to compare X and Y or A and B. You want to compare 0 and 1. What we are looking at is the encoding. So we say 0 is the encoding for A, 1 is the encoding for B. To compare the two of the encodings, to compare the two values, we use the encodings. So this is just the easier way to explain what character set and collation means. So we want to check for the quality of the two values. We apply a collation to our character set. Checking for the equality of A and B means that we apply a collation to the character set. Okay, so that's the short definition. So we want to look at the engines that we have. We can use this show engines command, and then we should get all of the engines that we have. So we've seen this before. We've seen if they support transactions. We see that InnoDB supports transactions, sequence supports transactions. We want the storage engine that supports transaction, and it's already our default storage engine, which is InnoDB here. And so that's what we are using already. We want to look at the default character set. We want to check the available collation for our character set in the information schema. We can run a query. So these are just things you do maybe as a database administrator before you, or even when you create a database. Sometimes you want to take note of the collation you are using for your database and for all the tables and columns, because not all applications will come with the same thing. So we want to select the collation name. We want to select the character set name, and we want to select this from the information schema. Let's say from this is not case sensitive, so I'm just using the cases anyhow. Information schema. But by convention, we want to use keywords with uppercase, column names with lowercase. These are column names, but I put them in uppercase. I'm just saying that so you don't get confused. So we're selecting this from the information schema database and the collations table. And we want to say where the character set name is equal to. We want to see the collations available for UTF-8 MB4. And we want to get the, well, we can just stop here where the character set is this. Let's look at all the collations for this. Let's even order by collation name. Okay, so let's run this query. So now we see the collation name and the character set name, the character set it belongs to. So we can see for the UTF-8 MB4, we can see all the collation that we have. What I want to use is always Unicode CI most of the time. You can use any of them, General CI, you can use Crunch or Hungarian. You can see now this caters for the different kind of language that you're going to be dealing with mostly. So if your texts are mostly in a particular language, let's say you are doing more of a Danish or French language write-up, you're not dealing with English or something, you might want to use the Crutch CI and so it will handle a lot of the characters and the diacritical marks and whatever the language comes with. Okay, but I want to use Unicode CI here, and this will account for the majority of the letters and alphabets in many languages, not just the English language. So I'll just go with Unicode CI. So every time I specify my character set name, I'll use UTF-8 MB4, and my collection will be UTF-8 MB4 Unicode CI. You can read more about this and go deeper in it if you're a database administrator. It will help you to be able to understand and create the settings for how these tables and engines, and it's all of this will affect your database, your table, your data, your performance, and everything. So these are some basic things that you need to do before you even start creating a database. Okay, is there anybody with questions before we go further into creating our database? Okay, if there's nobody with a question, let's go back. So we have this hypothetical scenario where we want to create a database for a school. We say that we want to have users. The users will belong to either the admin, the teacher, or the student role. And within these roles, there are different permissions. So let's look at how to create database in MySQL. To create a database, you use create database statement. So you say create database, and then if you want to learn in the best way, let's learn good practices from the beginning, always use if not exist. So if the database exists, it just ignores not creating it and you don't have any error coming up. Because if you say create database and you don't use the if not exist here, what will happen is that if that database exists, it's going to raise an error for you. So we want to always use create database if not exist, and let's say the database we want to create is called, let's say, school. So the name of our database is school. Now, when you are creating a database, you want to specify the character set and the collection for the database tables columns. You can actually specify collection and character set for each table if they change as you go along. So let's say create database if not exist school, and then we say character set, and the character set here will say UTF-8 MB4. And then we want to say collate, and the collation we want to use is UTF-8 MB4, and we said Unicode CI. So we have created the create database if not exist school, and we have character set. This character set, there's no underscore, sorry. Yeah. So character set UTF-8 MB4, collate UTF-8 MB4 Unicode CI. So take note, the keywords here are create database if not exist, and then you put a name for your database, any name you want for your database, and then you put the character set, you write the name of the character set you want to use, and then collate, and then the name of the collection within the character set that you want to use. So every character set has a set of collations, and you choose one. And so we'll say go, and if all is well, we'll have a green tick, and we'll see a database school created here. So we have a database called school, and I have selected that database. Now we have a database. Before we start storing data, we have to create something we call tables to hold this information. It is from tables that every other thing is created. The views we want to have, the stored procedures we want to have, we're going to be doing that from the tables. And for us to create tables, there are also other things that we need to know. So if you want to list all the databases that you have, we have this command will say show databases. And for those of you who are database administrator, you'll find that you do this from the command line. And so I write these queries like this without clicking so that you can know how to run this query when you're working from Linux. See? So you can see the name of all the databases that you have with your on your server. Okay, so when we have a database, we need to store information in it, and this information is stored in tables, which stores data in rows and columns. with each row representing an information, and each column tells you the type of information that is held for the different users. So let's say in our database, we want to store information for all of the staff, the admin, the teacher, and the user. But we want to focus on the user part of this now. So for us to do this, let us first of all look at something we call constraints, because we need to create tables. This table have to have columns. These columns have to have definitions. These definitions will decide what the data types and the constraints we want to enforce on these tables are. So let's look at the different constraints. We have something we call not null. When you create a table and in the column you specify not null, it means that column must have a value. You cannot save information into on that row without putting a value in that column. We have unique, which means that no two people should have the same record in the same cell for any column that is specified as unique. We have something we call primary key. And when we say primary key, it enforces not null and unique constraints and uniquely identify each rows of that table. So sometimes we want to have the index be the primary key, depends on what you want to do. We have something again that we call the foreign key. Now, the foreign key keeps the links between tables and prevents actions that will destroy the links between the table. We have something we call check. We're saying check like this, and when we have check, we just ensure that the values in the column satisfies a condition, and we have something called default that we use to provide the default value whenever no value is specified in a particular column. Also, we need to understand the different data types that different columns will have. In MySQL, data types are something like when we say char, and then you specify the size. When we say char is a fixed length string, this can be letters, numbers, or special character. The size parameter, this size here that we have here, specifies the column length of the character. So we can always have it from 0 to 255. I think from 0 to 255 is the column length for a char. Now we have something we call varchar. When we say varchar, it's just a variable length character, can contain letter, number, special character. This size now does not contain fixed length. Like when we say char and we put size, it has to be that size. It's a fixed length character. When we say variable length string, so it's a fixed length string, when we say char, it has to be the length, when you specify the length, it's that fixed length. When we say variable character, it means that we're only specifying the maximum it can take, not like it's fixed. So if I say 255, we can have something of a text of length 50 characters, but the maximum it should be is 25. After 255, it will truncate. So that's why we call it varchar, like variable length string. We have something we call binary, like this. And when we have binary, we specify size here also. It's the same thing as the char, but it stores binary byte strings. The default, once you don't specify size for both the char and for the binary, I think the default is 1. And so you can use this parentheses here to specify the column length. And that column length is in bytes. We also have a binary, just like the varchar, and it's the same thing like the varchar, but also it stores binary byte strings. What you specify in the parentheses is the maximum column length. We have other types that we will not use in this course, but you just need to know them. We have something we call tiny blob, like this. And these are for binary large objects. The maximum length is 255 bytes. We have tiny text that holds string with a maximum length of 255 characters also. We have text. We'll definitely use text. So when you're collecting user inputs from a text field, a whole lot of text, you might want to store them in text. And in this text, it holds a string with a maximum length of 535 bytes. And we also have blobs for binary large objects, which will also hold up to 535 bytes of data. We have something we call medium text that holds just like the text also, but the maximum length is over 16 million characters. And we have medium blob, which also holds over 60 million characters. Long text holds up to 4 billion characters, and long blob holds up to 4 billion characters. We have enum also, and when you say enum, these are the ones we will use like this, and you specify values. This is a string object that have only one value choosing from a list of values or possible values. So you can list up to, I think it's 65,535 values in an enum list. And if the value is inserted and it's not in the list, a blank value will be inserted instead. So like if you want people to select between yes and no, and if the answer that they have, that they fill on the form is not yes or no, it will make it blank. So it will always know that what you are specifying as your enum is either a yes or a no. That's what enum means here. Okay? So enum, yes or no. So that's what enum is. Or any list of values, maybe a set of colors. The same thing with set. So set is a string object that can have 0 or more values, choosing from the list of possible values. You can list, I think for the set is about 64 values, but you don't have to choose from that list, but you just want to have a predefined list of values there. Okay, and all these data types that we just talked about, they're all string data types. We have numeric data types that store numbers and decimal numbers, bits. And when we say bits and we specify size in parentheses like this, the number of bits per value is what we specify as the size. The default value, the default size is 1 and it's from 1 to 64. We have tiny ints. Tiny int like this. Tiny int is a very small integer from range, I think -128 to 127, or from 0 to 255. So if you are using negative values, it will be -128 to 127. And if you are using positive numbers or unsigned numbers, it's 0 to 255. The size parameter here, when we put here, we'll just specify the maximum display width that you want. We have another one we call the bool. And for bool, we have 0 is false, 1 is true. Boolean is just yes or no, true or false, 0 or 1. Okay? Then we have something we call small int. We can also specify the size here, and small integer and is larger than the tiny int. This ranges from -32,768 to 32,767 for the signed values, and for the unsigned rate is 0 to 65,535. When we specify the size, the size just gives us the maximum display width. That's what we'll specify in the size parameter. We have medium int, which is the same thing, just that the range of values is a little larger than the small int. But that is, I think it's about -8 million, over 8 million actually, so +8 million. And when is the signed one is 0 to over 16 million. And then for the int, which is the one that we use most of the time, we just specify int. Int is just like a medium integer, but the signed range is from -2 billion to +2 billion, over 2 billion actually, and unsigned is from 0 to over 4.2 billion, thereabouts. Okay, so we have big int, we have floats. You can also use floats too. When we say we have floats, it's just a floating point number. The total number of digits is what you specify in the size parameter. So we can have something like a size here. Let's say we have the size, and then we'll specify D. The size is the total number of digits we'll specify, and when we say D is the number of digits after the decimal point. Okay. But I don't even know if this syntax still exists in the current version of MySQL, but just in case it exists, this is what it is. Okay, but normally it's just the floating point, float like this, floating point number, and you determine whether to use float or double for the resulting data type by specifying something there. So if you put for this value of P, if you make the value from 0 to 24, the data type becomes float. And if you put it from 25 to 53, then the data type becomes double. That's what it just means. Okay. So we have other date time data types where you say date. When you specify date, it has the format of 4-year format, 2 months, and 2 day, like this. So if you specify dates, this is the format that it is going to insert your date in data database. If you put date time, it is going to insert it in the 4-digit year, 2-digit months, 2-digit day, and then 2-digit hour, minute, and second. That's for date time. If you do timestamp data type, the timestamp is stored in number of seconds since the Unix epoch. So number of seconds since 1970, January 1st. That's what it is going to store it in. And it's going to be in the format same as the date time of 4-digit year, followed by the month, followed by the day, hour, minute, and second. Okay. Okay. So these are some of the ones we'll use. You can research to look at more of them. You can actually use time like this, and the time will just give you the time, hour, minute, second. And if you use year will just give you the 4-digit year format. You use year like this. All right. So these are the major data types in MySQL that we'll be using. Research them, look at their meanings, and look at how we use them. So let's go ahead now to create our table, since we know what data types and constraints are all about. Now, from our hypothetical scenario, we want to use the school database. So you can just say use school. I already selected it, so I'll not write this. So when you use school, you want to create a table. Now the syntax for creating tables is create table, and it's always good to use if not exists, like this. So we want to create table if not exists. What table do we want to create? Let's say we want to create a table called users. We want to create a table called users because we are trying to do the authentication system. Now, before we even create the users, these users are going to be assigned roles and permissions. So we want to start with the things that will be assigned first. We want to have our predefined roles in the database. And so we want to create the rows table first. So we'll say create table if not exists, and we want to create rows. Now, when you write this, you put a pair of parentheses, and it's within the parentheses that will define all of our columns, the data types and the constraints for the columns. Now, we want to have a primary key. Let's say this row will have an ID. Let's just name them 1, 2, 3, 4, 5 for each row number, like serial number. Let's name this column ID. Now we want this to be an integer, so int, that's the data type. So you specify the name of the column, the data type, and now let's put the constraint that we want. We want this to be the primary key, so it enforces both uniqueness and not null. We don't always want to insert value into this. We want it to just auto increment, like from 1, 2, 3. We use the auto increment constraint also. We put a comma and we define the next column. Okay. So what we have just done here is we have one column in this table. So the next column we want to have is, if we want to have the role ID, we can also have role ID if you want to. And let's say the role ID is maybe alphanumeric character. So let's say it's the varchar, and let's say the maximum length should be 10, for instance. We can use char and enforce a fixed length. So we'll say the maximum is 10 varchar. We want this to be unique, and we also want it to be not null. So I'm just doing something hypothetical for you to see how to create a table and the columns within the table. Now we want to create a row. This row is also going to be a string of characters, right? So we'll use varchar, and let's say the maximum size, let's just use 40 for the maximum, and then we'll say this is unique. Let's say this is not null. Now, whenever you create a column and you say not null, sometimes you want to provide a default value that will be inserted in case the user does not provide the value. Let's say for this one, let's do an example of default. So we'll say default, and let's say the default will be admin. So let the default role be admin inserted if no role is assigned. So we'll say default admin. So we've seen how to use a constraint. Once you are done, the last column definition, you won't have a comma there, if not you have error. At the close parentheses here, you want to do something. Specify the engine, the default character set, and the collation. So let's say the engine we are using for this is equal to, so we know the default. You don't have to do this because we know the default is InnoDB, but I'm just showing you. When you ever see this anywhere, you understand what it means. Engine, InnoDB, and then we have default. So we have default char set, and the default char set here will say is equal to UTF-8 MB4, and then we'll say collate is going to be equal to UTF-8 MB4 Unicode CI. So we have one table. Anybody has questions?
No question from here.
Okay. We want to create a second table, which is now the permissions table. Now, because from the hypothetical scenario that we gave, we say the roles we want to insert are the admin, the teacher, the student. And we want to say the admin has the record appraisal, the approved results. We say the students have the mark attendance, the teacher has the mark attendance, the grade script, and the students have the submit assignment and the view results. We use permission to control what the user sees on their page, what functionalities, what drop-down menu displays. So when you have two users that are assigned the same role and they see different things on their screen, they have access to different functionalities. They are being controlled by permission. So when you are building your authentication system and you're using access control, you will have different ways you can define your access control, either by roles of permission or by any other criteria that they choose to use. So let's create the permission table. It's the same syntax we use. Create table, if not exist. And the table name is called permissions. Okay, we want to create a table if not exist permissions. In a pair of parentheses, we are going to define them. The column definitions. I'll just copy this and put it outside this. Okay, so create table if not exist permissions. We want to put an ID here, and our ID is going to be the same definition here. Int primary key auto increment. I just put that. We want to have permission ID, and let's say this will be virtual. Let's put 50. Or let's even put 10 because, and let's say the permission ID will be unique to each permission, and let's say we want to enforce not null. So I'm just doing it this way, so just so that you can see how to put different constraints. Then we want to say the permission names now. Let's say the permission name is going to be virtual, let's say 50, and we'll say not null, and default. Let's put default permission. Let's say somebody's a super user, want to give all permission. Let's just do it like this for now. And now these permissions are associated with a role. You want to know what roles you can assign these permissions to. You don't want to have loose permissions that are just there, and you don't want it to be under a role. So if we are using something on the front end like jQuery or JavaScript, and then in the drop-down menu we are creating users, we select the role. We just want the list of the permissions to be permissions that are associated with that role, to be able to assign what permissions within the role the person can have. Now, because these permissions are associated to a role. We want to know the role that we use here. Now I want this role to be varchar 40. So there are two ways we can do this now. We can either link this to the role ID. We can use role ID here, or we can just use the role. Let me use the role ID. Let's do it a little more professional. And we'll say varchar 10. So we want to link this to the role ID of the role. So when the ID is linked, it automatically knows the role because it's linked to the ID. What we do here is use a foreign key. And let's say this is not null. How do we complete this definition to link these two tables together so that the permission will know that this row ID they're talking about here referencing this row? We use something we call a foreign key. And we define the foreign key like this. This is one way of defining it. This is the way I like to define it. There are many ways to do this. So I'll say foreign key. So the foreign key is the row. So the foreign key now is the row ID that we just added here. This is a foreign key. Let me explain this foreign key for you in a way you can understand better. If you have, let's say for instance, you are the father now. You have children. Your children will take your last name, right? Your last name is a foreign key to your child. That last name is linked to you. Your child has a last name that references you as the father. You are the parent, the person is the child. The role table is the parent, the permission table is the child table. So anytime you hear about parent table and child table, it just means the parent means the person who holds that definition, and the child means the person who uses that definition or that name or inherits something. That is the definition of foreign key. We reference them so they don't get lost. Your child has an identity when the child uses your last name. We know that that child belongs to this family because you bear that name. Everybody who has that last name are linked together in a family tree. That okay, this is my family tree, this is my father, this is, so all the link between that is a foreign key. That is the definition of a foreign key. So now we want to say exactly what table is the parent that this row ID is talking about. So foreign key here is the row ID. The references now. So references now will be, we're referencing the rows table and we're referencing the row ID column from the row table. Foreign key, you specify what column in this table is the foreign key. References, you specify the name of the table and the column in the table in parentheses that we are referencing for this foreign key. Right?
Please, I need you to go over that again, please.
Okay, hold on. So I was saying that the best way to think about foreign key is to think about the family tree, where you have the father, you have the children. They all have their last names in common. The father, the parent, is the original owner of the last name. Because those people are the children, the grandchildren, the offsprings. They have that last name. That last name is a foreign key for that child. The definition of a foreign key in MySQL is that the column that is used by other tables, that table that holds that column originally is called the parents table, and the other tables that use that column definition is called the child table. So this permission is the child table for the row table, which is the parent. Now, what is that thing that links both of them? So in this our example, role ID is like the last name that the children inherit. And so we use the role ID here, which the parent role have in common with the permission. So when we specify a role ID column for the permission table, we want to create that link of integrity so that the links are not broken. We want it to bear the same last name as its parent. And so the role ID now is their last name. And you want to link this last name so that it will not be like the last name is Mark, but it's not Mark from the same family. We want to make sure it is Mark from the same family. And so we specify something we call foreign key. The foreign key keyword we specify here in a parenthesis, we want to list the column from all of these that is a foreign key, which is the row ID. That means it is that column that is inheriting from somewhere else, from a parent. And the references here, we want to say which parent you are having this foreign key from. So the parent table name is rows, and the column or the last name for that parent are referencing is the row ID specified in the parentheses. So do you understand it now?
I'm better now. Thank you.
Okay.
Thank you.
When you do this, you want to specify what happens when these parents, let's say for instance, the role is the father now, right? So when this father dies, should the child automatically die? When this father changes their name, should the child automatically change their name? You want to specify what happens when you delete or you update from the parents table. So let's say on delete, what do you want to happen? Do you want to say restrict? If the parent is deleted, you don't want to allow it to delete because the permission holds the name. We can't delete the name. Or you want to say this parent cannot commit suicide because the child will automatically die. So we'll stop that from happening. Do you want, if the parents die, you want the entire generation to go? So you say on delete cascade. So once the parent does not exist, we don't want the children to exist, we cascade. So when you say on update, if the parent changes that name, you want it to change for all the children automatically, cascade. So you can use cascade, you can use restrict. Restrict is don't allow it to happen, cascade is let it tail down. Whatever happens to the parents should happen to the children. So when you do this, you are done. If you have many other columns that are foreign keys, after this you put a comma and specify another foreign key. So if you have many foreign key columns, you specify them one by one. You can just copy this and paste and change the column name and the parents table and continue, just keep putting a comma. But if this is the last no comma, and you're done. So
Hello,
yeah.
Now, are you saying we can have more than one foreign key in a child's table?
Yes, you can reference several foreign keys. You can have many links. Just put a comma and just continue to list them. So you start again, foreign key, column name, references, the parent table, the column ID. So you can have many of them.
So for foreign keys that we want to list, these are like specifications that must follow. The reference, on delete, and on update.
Yeah, an update, yes.
Okay.
So this thing that we did here, there's a way you can specify all in one list. There are different ways to do it. In order not to confuse yourself, just do it this way.
Okay.
There are other ways this can be done. The even more elegant way of writing this, but it's more confusing. Okay? So we've done that. We've linked the row. We've linked the row with the permission. This is one of your assignment 3 for course 2C for batch C. So I've practically done that assignment for you. So I'm not going to do the rest of the assignment. So we've seen how we have linked the row and the permissions table. Now let's say we have the users table now. We create the user. The user will also have a foreign key that is the role that we want to assign to that user. And the user will also have the foreign key. So we assign the role ID and permission ID. So let's do the users, for instance, so that you can see when we can have more than one foreign key for a table. So we'll say create table if not exist. And so create table if not exist, we'll say users, right? And we want to just copy and paste this. This is not really necessary actually, because we have that in our database definition. Okay, so we say we want to create this. Let's use ID, and with the same thing, int. We want it to have auto increment. We want it to be the primary key. Every table must have one primary key. Okay. We also want to have, let the user be identified by their emails, since emails are unique. We want it to be virtual. Let's say it's going to be encrypted, so we want it to be length 200, and we want it to be not null, and also want it to be unique. We want to have the password for the user, and we want password also. Let's say it to be encrypted before storage, so we need a long length, 200, and let's say the default password will be null. Then we want also the row. Now the row, let's use row ID. So let's just use the ID. So this is varchar 10. So you want it to be the same length with the original, the further. Varchar 10, we'll say not null. Then we want to have we'll just leave row, but we'll have another table called user permissions when we link the user to their permissions. So let's just leave it as row here. Oh, I'll put the permission here. So let's do it in one. So it can be different from your assignment. So permission ID, let's put varchar 10. And let's say not null. So this is an example that is different from your assignment. So we have these users. We want to illustrate how we can have two foreign keys for one table. So I'll just copy this because we need the row ID foreign key here, and I'll paste it here. Then I'll put a comma again and paste the same thing, but I'm going to change the value here. The foreign key I'm having here is the permission ID. And this is coming from the permissions table. And it's the permission ID column. Okay. And then I put on delete cascade, on update cascade, and that is all. So let's even see if all is well with this before we continue. Now I've created 3 tables, and I'll click on go, and all is well, everything created. When I come to my school, I can see my 3 tables created. If I want to go to, let's come to SQL here. I'm trying to look at the link between these tables. I think we can look at more designer. So when I look at this, I can see the link. So we can see the link now. For permission and the rows, from the permission table and the row are linked by the row ID here. Can you see the link here? And between the permission and the users, they are linked with both. Is linked with the user and permission is linked with the permission ID column, and user and row is linked with the row ID column. So you can see the users have 2 links to each of the tables. Okay, so for those of you that design models, and so this is what you will do when you're designing model. I think there are apps to design model. If you're designing a database for an application, you want to design it with a link before the person who will actually create a database will start creating. So is it understandable?
It's understandable. Yeah.
Okay. So for those of you in batch C, you will follow the instructions in the assignment to complete the assignment, and follow the exact instruction. This will give you a head start and practically answer most of your questions in assignment 3. All right. So let's look at how to insert records and update record on a table, and then look at views before we end MySQL. If we want to insert record into a database, by default, I think auto commit is set to true in MySQL. We want to set auto commit to 0. We want to use transactions. So set auto commit equal to 0. Why are we doing this? When we use transaction, we want operations that will all succeed together or all fail together. When we want to insert into the permissions table, we want to make sure that the role even exists for that permission. So we want to make sure we're inserting everything at once. This is not a scenario that makes much sense. Like in your pre-recorded videos, you find a more sensible scenario. And one of the most sensible scenarios we can use is like a banking application. I want to withdraw money from my account. I go to the ATM. I insert my card. I select an amount. As soon as I withdraw the amount, I check my balance is deducted from my balance. Right? Or let's do like an online bank transfer, mobile transfer. I want to transfer money to another account. I select the amount I want to transfer. The money goes to the other account and simultaneously deducts from my account. That happens in a transaction. The transaction happens that everything must succeed together. The money transferring to the recipient's account and deducting from my account must exist as a single unit or fail together. So if the money does not go to that account, it should not deduct from my account. If it goes to the account, it should deduct from my account. So those kind of things are the things we use transactions for, where you must have a group of operations that must either succeed together or they must fail together and roll back. Does anybody have a question?
None from here.
Okay.
No.
All right. So we set auto commit to 0, and then we start transaction. So we have a more complex type in a pre-recorded video so that you can watch over and over again. I'm not going to give you any headache this weekend, so I'm going to make it simple. So we'll start transaction, and let's say we want to insert into the roles and permission table. We want it to go as a single unit. This is not the best example of transaction. The example I gave you is when you're creating a banking app, you're transferring money. You want your money to be deducted from your account as long as it enters into the recipient account, or not to be deducted from your account if it's not going to enter the account. Now sometimes you have bank with some crazy applications that you will get a transaction alert, your money is deducted but the recipient never received, and you start writing letters to the bank. Those are app failures, those are software failures that they have. So we have this, we want to insert into roles, and then we insert into permissions. So let's say the syntax for inserting is insert into. Now, I like doing things the proper way from the beginning. If I want to insert a record into a table and that record already exists, or the primary key already exists, it will give me error, right? And it will halt the process. So instead of me to have problem of this is not inserting, I'll just write insert ignore. When I say insert ignore means that if this data already exists, just ignore and continue. So I'll say insert ignore into rows, and what we want to insert here, we want to insert the role ID and the role. Because the ID column is auto increment, you don't need to specify it because it automatically inserts. So role ID and role, and then values. The syntax is insert ignore into the table name and the column names in parentheses, then the values you want to put in the columns. The order in which you list the columns is the order in which you should list the values. So let's say we want 001 and we want this to be, we say admin is one of the row, and then we want to have the same thing. You can even list them all as a comma separated list. Let's just do it one by one. Like we said, we want our weekend to be good and free of headache.
Hello, ma.
Yes?
Insert ignore. Why the ignore? I didn't get that point.
Okay, so you use insert ignore just like we were saying, create database if not exist.
If already exists. Okay.
Yeah, so if we're saying insert, if you put ignore there, it's just to let it know that if it exists, just skip it, forget about it. No, don't give me error, don't halt my process, don't crash the system. So that's why I put ignore there. So the second one is we have admin, we have teacher, right? And then we want to insert student. I hope this is even correct. Student. So we want to insert here. And then we also want to insert into permissions. So insert ignore into permissions. And we want permission ID. And permission. And the values for the permission, let's say we have 001, and then the permission name, we say we want to have, and then we also want to have the row ID that this belongs to. When you are working with this from the front end, the row ID will automatically select a drop-down list from the row, and so the user will not even have a free field to type. It will just be a drop-down menu that they'll select from the predefined list of rows you have on your database. So as we are not doing front-end in this course, we don't see all of that. And so let's put the row ID here, and the row ID here is, let's say, 001. We're just making this a string, just in case. So insert ignore into permissions, permission ID, permission and row ID. So put the permission ID. The permission here is not admin. We have record appraisals. So this is underscore. See, I've forgotten my spellings. Okay, let's say record appraisals. And then the permission, the row it is associated with is the admin row, and the role ID for that row is 001. So let's just do this like this and test if this is okay, or work our way back if we have errors. So let's say we want to insert the second permission. Like I said, this you can do this in one list, like you specify insert ignore into permissions once, and the values will become a separated list of all the values. But we are going to keep it one by one like this, find our errors, and when we become professionals, we begin to do it all at once. And if you want to do it all at once, all you need is just a parenthesis here, comma, a new parenthesis to list more. Okay? Okay, let's do the second one to be a new parenthesis to list more instead of writing this whole thing. I just want you to see the different ways of doing this. This one is going to be approve results. And this is still 001. So let's say this is 003, and we want this to be mark attendance, and it's going to be, or record attendance, any English that fits better. And then this is associated with the teacher role. Then you can put a comma and just list only the value instead of writing this whole insert ignore again. And then the permission ID here will be PAM 004. We'll do, let's say, grade script, and this is also associated to the teacher. So we'll say the row ID is 002. Then let's do permission for students. We'll put 005. We'll have submit assignment, and this will be for students 003. And then let's do one more permission for the students. We have M006 006, and we want to put view grades. This is also a student's permission. Okay, so let's run this first of all to make sure that what we are doing even makes sense. When you finish doing this, if you don't put a commit at the end, it's going to roll back. You'll see it's successful. You click on the data base table and you won't find that record because it rolls back. It's not committed. For you to commit it, it means, okay, this is final. If everything is successful up until the end, this inserts into the role, inserts into the permission committee. If there's one problem anywhere, it just rolls back. If it has already inserted here, it just takes it out immediately. So it either succeeds together or fails together. This is the best practice if you want to keep to the ACID property, that you do all of this, insert and update in the transaction for things to all complete successfully or roll back if there is a failure on the way. Let's say go and see if this inserts. Everything is okay. We have all green check marks. It's a good weekend. When we come back to rows, we find everything inserted. When we come to permission, we find everything inserted. Now we see the row ID here that references the row. And when we click on that ID, it takes us to the father. So we'll see exactly where the dad is. When you come back here and you click on this, it takes you straight to the dad, the parent. So this is what we call foreign keys, and this is how we link our tables and we keep integrity of our data. So in the event you have an application where you are creating a patient registration or a patient system, and you have one table that registers patients, like a registration, you have the hospital registration number. That hospital registration number is maybe a column on a particular table that holds columns like first name, last name, and all demographic information for the patient. Now, when you go to other tables that hold vital signs and clinical records, you don't need to list the patient name. You just reference the hospital number. And whenever you want to find out how this hospital number, who does it belong to, you click on the hospital number, it takes you to the parent that gives you all the demographic information about the patient. That way, it even limits your encryption and the identification of data, because what now happens is you only have to bother encrypting one table that identifies people, and the rest of the table just has a number that doesn't make sense. Everything is encrypted. Nobody knows who it belongs to. So that is one of the ways you make choices of what kind of database, engine, collation, data set that you want to use, or character sets that you want to use for your database design when you are building an application. Is this understandable?
Yes, it's clear.
Okay, please, ma, I'm kind of lost in the inserting into permissions. And then the numbers you are assigning, how do you just give any number? I want to understand.
Okay, let me do the insert query again. So if you want to insert, you say the syntax is insert into. If you don't want to have errors, you just use insert ignore into the name of the table, you say permissions, right? Now, this table, you want to list all of the columns in the table in the order in which you want to insert the values. So I want to insert into the permission ID column. So sometimes you're not inserting into all the columns. You just choose the columns you're inserting into. Make sure that you are inserting into all the not null columns. If not, it is going to give you an error if there are no default values specified in the table definition. So we have permission ID, we have the permission, and then we have the role ID. So these are the columns we want to insert record into. But what values do we want to insert? So values, and in the parentheses, you specify. So if you want to have several values, like different rows of information, you want to put 10 people's record, you put comma and many parentheses, and in these parentheses, you are going to specify all of the values that you want to specify for these columns. So these are different rows of information. These are 4 records you want to insert. The values you specify should be in the order of the way you specify the role. So permission ID. The ID can be any ID. You are the one that will give it the ID, depending on whatever it is. So if you have, for instance, we say you have different states in a country, and the states have state codes. So if you say Abuja will be given ABJ, so that will be the ID for that state. So the state ID will be ABJ. So these things are things that you define what the permission IDs are for the different permissions. That things you define. If you have an algorithm, fine. If you want to randomly define them, fine. Then you put
Sorry for breaking, ma. You know, the other time you specify in the role like that it's auto-generate, right?
Yes.
Now, if, for example, you just mention something for maybe states, now want to define it with maybe short forms like ABJ for Abuja, LG for Lagos, the auto-generate, is it still going to be there?
The auto increment is just like for the serial number 1, 2, 3, 4.
Yeah, the auto increment, yes, ma'am.
Yes, still be there because we are not assigning into the ID column. We make the ID to be the index and we made it to auto increment. So because you're auto incrementing, you don't bother to put it, to automatically do this one as number 1, number 2, number 3, number 4 by itself because you specify auto increment.
Okay.
Yeah. So now your permission ID is going to be the value that the user entered, that you are putting into the database. The permission is going to be the name of the permission you want to insert. The role ID is now going to be the ID of the role that is the parent for this child. Okay, do you understand it now?
Yes, I do. Thank you.
Okay. So the next parenthesis will hold another set of values. Again, the same permission ID, permission role ID until you are done. Okay. Sometimes there are certain queries that you don't want to run 1 million times. You're always running that query. Let me think of an example of those kind of things. Let's say, like in the secular database, we always want to link the actor and the films that they have, and we use a join to do that. But we don't want to do that. Okay, let's just even use this example, this one that we're using, the permission, the role, and the users. I'm thinking of the best way to illustrate this. We have these permissions inserted 1, 2, 3, 4, 5, 6. We have the permission IDs, the permission, the role ID. We have the role ID, the role. We have the users. So let's say we don't have anything in the users table. But let's say we want to have the email of the user. We don't want to have the role ID. We want to have the name of the role and the name of the permission or something like that. Let's just create something. We can run a query to get that. Let's say select a.email, right? Before we do this, I think we might have to insert into the users table, or no? The user has the email column. The user has the row column, I think. A.row ID. Let's say b.permissions. B.permission. So let's see what we are trying to do here. We want to look at this row, this permission table. We have the permission ID, but we don't know what permission this is. We want to match the permission and the row that they belong to. Let's do something as simple as that. The permission and the row that they belong to. Let's do that one like that. So we have in the permissions table, we have the permission ID and the row ID. In the rows table, we have the row ID and the row. So I want to select a.row b.permission from row A. Let's say inner join permissions B on A dot role ID is equal to B dot role ID. So let's do something like this. When we run this, sorry, there's a school dot role dot and rows, sorry. When we run this, we still have no column a.row. Sorry, oh my god, role is the name of the column, rows is the name of the table. Yes, I think this is what it's supposed to be. So when we run this, we have the row and the permission. So now we have merged the permission and the role it is associated with. We don't have this on any table. Let's say you are the admin, you want to have a view of things, you want to have your admin dashboard that views these things. You don't want to have to run this query every time you want to see the permissions that the different roles have. You don't want to see it, or you don't want to run this query all the time. You can store this in a view, and the view is there automatically every time. How do we create views from tables? Every time there's a query that is going to be run all the time, especially when you are building a surveillance system or something that you do data analysis from, you want to put your reporting indicators or all of your algorithms in a view to just have that, and so you just run a select query on that view. How do we create view? We say create view. Again, good practice, we just say create or replace. And when you do this, is if it exists, replace the definition of the view. If it doesn't exist, create it. That's why I say create or replace. So create or replace view. So want to create a view called let's say row permissions, for instance. Has And then when you put the has, you put the parentheses and you put the definition, what query you want to run to create this. I will paste that query I just did. So this whole join that I did, I don't want to run it more than once. I want to store it in view. View is just like a table, only that it is a view. Because they have the same namespace, a table and a view. So once you have a table called rows, you cannot have a view called rows. They must have unique names, but it's a view. When I say go, you can run query against a view, but you cannot run operations like insert and update and delete on a view, because the view just reads from a table. You only do your select query operations from a view to make it easier for you. So we don't have to run join all the time. We'll see now we have a views here. When I see my row permission, every time I click on it, I have the association stored in a beautiful table waiting for me. So I can just say select all from row permissions in any query I'm running. I don't have to use that crazy joins all the time. I do the join once, I have it, I store it as a view. So that's what a view is. So when you're creating large applications, you always have views. We are going to look at stored procedures in part 3, but views is something very powerful that we use when you have large applications. You want to always query records across several tables. You just want to create a view that has that result in one place, so that you just query that view. Is it understandable?
Yes.
Okay, so another thing we want to look at is how to update records in a database. We have not looked at this before. Let's say after creating this, now we can see the view. We have this. Anything that happens on the table will automatically change the records in the view. You don't have to do anything with the view. Once you create it once, all you do is select queries from the view.
Hello, ma.
Yeah.
So from what you are saying now, on the view, we cannot carry out this acronym GRUD, right?
No, you can't. You can only select from the view. Yeah.
The only thing we can do is just to create it so that we'll not need to be, running that complex joining command each time, right?
Yes.
Okay. Thank you.
Okay. So when the original tables that make up the view changes in data, the view automatically updates. It changes automatically. You don't have to do anything. Okay. So we have, let's say we have the rows table. We want to change this teacher to faculty, for instance, the role name to faculty. We have made a mistake. We don't have a role called teacher. We want to call it faculty. What do? We use an update statement. So let's go. The role ID is 002. The role name is teacher. We will choose what uniquely identifies this role, teacher. The role ID uniquely identifies it. So we want to update by something that uniquely identifies. And why do we use something that uniquely identifies? If you use an update query without specifying a unique thing, you are going to be updating everything that satisfies that condition. Okay? So we use the unique value for this is the row ID. Let's run an update query. The syntax is update table name, want to update row. So we're updating rows, then set row name, which is row. We want to set row is equal to faculty, where role ID, which is the unique column, is equal to 002. You see the update query? The syntax is update table name, set column equal to new value, then the condition that you want to use to make sure this update happens, where the role ID is 002. You have to identify where am I updating, what am I updating. If I say set role equal to faculty without this where clause, it's going to set all the roles equal to faculty because there's no condition. You just say set it and set everything. So now you have to put this where clause to make sure you do not overwrite all your records. Let's even see if this is correct. So 002 was teacher, we want to make it faculty. And now this says one row affected. When we come to the rows table, we shouldn't have teacher anymore, we have faculty. So because we put our foreign key to be on update cascade, when we come to permissions and we click 002, it takes us straight to faculty. There's no longer any teacher. When we come to the views, we no longer have teacher, but we have faculty. So you see how the integrity, just one operation on one table, because these things are linked, we keep the integrity of the whole system in order. You don't have to go to each table and say, if there's no link, when you're updating the row, you go and update in the permission, you go and update in the users permission, the whole system is all flopped out. And so integrity is violated. Yeah?
Now I want to ask a question. Now we just update the name of the teacher to faculty.
Yeah.
Now I look at the scenario where one takes backup.
Sorry, I can't hear you.
Hello, can you hear me now, man?
Yeah, I can hear you.
Yeah, I said in a scenario where, okay, I take backup of my SQL server, and I was taking a backup of that SQL server when the role was teacher.
Yes.
And now SQL backup server when the role is what's it called? Faculty.
Yeah.
Now that means it will automatically overwrite it.
No. You have logs. You always have logs at different timestamps.
Okay.
Yeah, you always have system logs at different timestamps.
Okay, from the system log, I will be able to see.
Yes, when something changes.
No, it's okay.
And then it depends on how you set your backup. You can actually trigger your backup to happen every time there's a major change or something. So they're just different ways people do different things like this.
Okay. It's okay.
Okay. So we see what it means by doing all of these operations using these different constraints to keep to an asset property. And when your database is like this, then you are doing things correctly. We have integrity of systems, and we can see in the world how many times we have system failures everywhere. And it's only because of bad developers, self-acclaimed IT gurus, building things without having to keep to some fundamental principles. And so you now have systems that keep crashing, keep failing, keep saying that when person A queries their own system, they find this, and person B queries, they find something else. There's no integrity. Tables are not linked, and it doesn't keep to the asset property. So this is where we end MySQL. And anybody with questions, you can ask now, and we're going to switch over.
Before you end, you talk about conditions to look at before creating a database, and you mentioned the hash seed, right?
Yes.
I know you said A for atomicity, or I don't understand that.
Yeah,
then X for
atomicity, C for consistency. So when we say atomicity, we want to say that each statement in a transaction, and when we say transaction, we mean the read, write, update, or delete data, is treated as a single unit.
Okay.
And when we say consistency,
consistency.
We want to ensure that the transaction only make changes to a table in a predefined and a predictable way. So when I say consistency, means that if I run this query now, the side effects I get must be the same thing if I run the query tomorrow, next tomorrow, if I run it 10 times today. So it has to be consistent.
Okay.
Yeah.
Then the high.
For isolation. And when we say isolation, we mean that when multiple users are reading and writing from the same table all at once, the isolation of their transaction will ensure that the concurrent transactions don't interfere with or affect one another.
Okay. Then the last one,
durability,
right?
Yes. Yeah. And that ensures that changes to your data made by successfully executed transactions will be saved, even in the event of system failures.
Okay, then what about the one you talked about that they succeed together, they fail together?
Transactions. That's transaction.
Is it part of it also?
Yeah, that's atomicity. That's in transactions. So that's why the atomicity is like each statement in a transaction. And transaction just means that when you read, write, and update, they must all succeed together or fail together. So when they succeed together, it commits. When they fail together, it rolls back.
Okay, so the last question I want to ask is this. For somebody, I'm setting up a database for a school, for example.
Yeah.
The website has been developed, and each of the transaction or whatever they are doing on the front end must reflect at the back end.
Yes.
Now, this database, is it that it's going to be created before the front end creation, or is after the front end that the backend, this database will be created?
Well, it depends. In most organizations, they do the backend before the front end. Backend people finish creating all their functions and database and models before front end people come and know what forms they're going to build on the front end to send records to the backend. So, like for people in course 3 now, you understand what I'm saying. I think we did that on Tuesday in course 3, where you look at forms, you look at the fields of information that you're going to be collecting from users. You don't need a front end for that. You create your functions that processes this information and send it to backend. That's where Python comes in between, right? So the information is entered on the front end. You click save. When you click save, it goes to a processing script. Your scripting language is Python. It looks through all the fields, sanitizes them, does whatever it needs to do with them, and then send them to the database table that you have created for each of the different fields. Now, all the times I've seen backend people finish building their system before front-end people come in. Or sometimes all of the whole development and project management meeting, both with front-end and back-end, come to an agreement. Front-end always uses the structure the back-end have created to build the forms and the interface and to know how to pull records from them with the different routes. Now, the people in batch A, you are already in part 3 I think today is the start of the routing and templates, where you begin to see how the front end collects information from the back. And for you to ask the question, I think you're in week 16, right? So in the next 5 weeks, you are going to see actually the answer to your question in one of your lessons, where we build the back end and build forms for the front end.
Thank you.
Sorry, who is asking? I thought somebody else was asking a question. Okay. So the next topic we're going to look at today is Python. Now, for those in both batch A and B, I think for those in all batches, even batch C, you want to even know this today because you're going to meet it very soon. You're starting Python in the next 2 weeks. So you want to understand what you're going to be doing. A lot of the things we are going to do now might go over your head, but it will give you an idea for what you will be facing shortly. Now let's look at error handling in Python. We have done a lot of topics and we've done them in different order. Now, some of these topics, Python is something that you can learn in one day, but you can't master it so easily. You need a lot of time and a lot of practice to begin to write Python professionally. And so I'm going to switch my screen to this. We want to look at how to handle errors in Python. In Python, there are 2 types of errors. We have syntax error and we have logical error or exception. Now, when we say syntax error, let's look at it this way. Imagine that you are building a house and you accidentally place a brick on the wrong spot. This is a syntax error in Python. It is a mistake in the code that will prevent it from running. For instance, you don't put an indentation. It is a syntax error. Something we call logical error or exception occurs when it has passed the syntax test and it happens at runtime. For instance, if I do 9 divided by 0. This is going to result in a 0 division error. The syntax is correct. It is going to go through, let's say print. Let me just put this. If name equal to main, print, let's print x. Okay. So 9 divided by 0, something like this. This is going to be an exception, or is going to be a logical error, because it will pass the syntax error. The syntax is all correct, but 0 division error is what we are going to get. So we have 0 division error, division by 0. You can't divide anything by 0. Why this is syntactically correct, this now becomes an exception or a logical error. Okay, so to handle errors in Python, we have this block that we use that we call try, and then we have try catch, then we have finally. This block of try catch finally. When we say try catch finally, catch is what we use in most languages, but in Python I think it is except. So if you write in multiple languages like me, you will always get confused. They're all the same. Catch except is the same. Try except finally. Try except finally block is what we use in Python. In the try block, you put code that might result in an error. So you put try, let's pass and write the code later. In the except block, you put what happens when something happens in the try block. So you put what will happen here if anything arises here. And finally is what you want to do regardless of what happens between try and except. Okay? Then we have something that we can do where that we say we can raise exceptions. If we raise exceptions, we do this for predefined conditions. Let's illustrate this let's use our banking app, for instance, for example. Let's say that we want to check the amount entered by a user against a defined maximum amount that can be withdrawn per transaction. So you go to the ATM. The daily withdrawal limit is, for instance, daily withdrawal limit is 1,000. And so inside the card, you choose an amount higher than 1,000. It should just give you a nice looking thing that this exceeds your daily amount for you to see, not a cryptic text and that will tell you all of this nonsense that you will not understand because there is no error handling. Okay, you want to be able to get the message, so you don't need to call the bank and be panicking and say this machine is writing something you don't understand. It should tell you exactly what the error is and what you can do to correct it. So at that point, when you see the error on your ATM machine telling you that you have exceeded your daily limit, you exactly know what you have done, and so you can reduce the amount that you are trying to get. Let's just write a code that mimics the ATM functionality. So let's do it like this. In the try block, this is what might fail here, because we know that people might come, they have $20 in their account, they want to withdraw 500. We know that there are people like that exist, want to see what happens. You want them to have a nice looking message so that the machine will know what it is doing. Let's mimic this thing using user input. So let's say user input is equal to, let's say input, and let's say enter, please enter your amount. Please enter the amount. Okay? So to tell the user to enter the amount. Now we want to use a condition now to specify. Now we have said in previous live class that when you use this input method, whatever the user enters, even if it's a number, it's going to come as a string. We want to pass this to an int. So we'll say if the conditional statement we use, so we're casting it to an int. So if int, so that we can compare. You can't compare a string and an int. So we'll say if int user input. So we store the value that the user enter in a variable called user input that is going to come as a string. and we want to cast it to an integer so that we can compare the value. And we'll say if this is greater than, let's say the daily withdrawal limit is 1,000. If it's greater than 1,000, we want to give them a nice looking text. Let's say print, you must enter an amount not greater than 1,000. You have exceeded, or something like that, your daily withdrawal limit. Like this. Else, you want to print transaction successful. So we're just trying to mimic it, like if the user input is greater than 1,000, we're just checking for greater than 1,000. There's other conditional things that will go on in the real world scenario. But what we are checking for now is if the user enters an amount that exceeds the daily withdrawal limit, we want to print a nice message to the screen, or we want to print transaction successful. Now, if the user enters something greater, we're already handling this part. But do you know we can use an except block here to write the kind of thing we'll get? We can get a value error. So let's say except, and we can specify a predefined error, value error, and put print invalid input, please enter a number. Why I'm putting this value error here is in the events that the user does not enter a number and enters a string. So I say enter a number, an amount, and the user decides to enter their name. You want it to run a value error. Okay? And regardless of what happens between this, we want to have finally block. We can put several types of exception, but let's just make it simple for you to know that. So regardless of what happened in this, in the finally block, we want to say thank you for banking with us. So in case the person just rejects their ATM, you always want to have that message, thank you for banking with us. So this is just one hypothetical scenario that we are trying to use to just mimic or to just illustrate how to do this. So in Python again, we use try, except, finally. You don't have to use the finally all the time. Try and except. When you use try, you use except. Except is going to catch the errors. Whatever error happened in the try block, you handle it in the except block. So the error we are going to catch here is in the event that the user decides to enter their name instead of a number, you want it to say invalid input, please enter a number. Okay? So let's run this. This is not the best example. I'm just illustrating error handling. So when I run this, let me remove this print x. Let me just remove all of this, and I will just run this. Okay. So when I run this, he asks me to enter an amount. Let me enter 1,000. All is well. Transaction successful. Thank you for banking with us. I'm going to run this again. He says enter an amount. Let me enter my name, and I get invalid input. Please enter a number. Thank you for banking with us. So no matter what happens, thank you for banking with us will always print. But now this except block handling is invalid input there. In the event I did not put this in the try catch block, I'll get some cryptic error message I will not understand. Now you want this error to be displayed to the user, so you use the proper message that the user can understand. If I run this again and enter an amount that is higher, and then it will tell you have exceeded your daily withdrawal limits, thank you for banking with us. So you see how the whole thing is working based on this. So this is just the logic behind those systems that we see and we think that one genius engineer created. We use our error handling and our conditional statement, and we are done. Okay? So basically, this is how we handle error in Python. When we start building our apps, our error handling is going to come into play in a very different way. We can actually raise errors or raise exceptions in a different way. We can say, let's raise error. Let's change this completely and say, let's change it from here. We don't want to print now. Let's say we want to raise error. It's a different way we do the same thing. We don't even want to use the try catch block. We want to get a user input. And when the user enters, we want to check this value. And we want to say that if this is greater than 1000, we want to raise an error. We'll say raise, and we're going to be raising value error, because that's the type of error that we're going to raise. The maximum withdrawal amount is 1000. Else, we'll say, please take your cash. Let's say print. Please take your cash. Something like this. It's just an example of raising error without using the try catch. So we can raise error within a conditional statement like this. When I run this, I'll enter an amount greater than 1000. So let me enter 6156. It will now give me value error. The amount should not exceed 1000. Okay. And then if I enter, run again, and I enter, let's say less than 1000 now, it will tell me, please take your cash. Okay? So we can raise errors like this. You have to practice this in different scenarios. There are more complicated ways of doing error handling. This is basically how we do it. When you're writing your app, you will know the different types of errors that we have. You can research to see all the different types of errors and exceptions that are predefined in Python that can occur. What does value error mean? What does indentation error mean? What does zero division error mean? These are all errors that Python has by default. You can define your own errors also. Does anybody have questions? But is it well understood?
Yes, it's clear. It's clear.
Okay.
Yes.
So we have looked at functions before, and we have talked a lot about functional programming. We have talked about iterators and generators. When we looked at functions, we saw how we can create functions for almost all app functionalities. And we said that when we talk about functional programming, input flows through a set of instructions, and each function operates on a set of inputs and produces some outputs. Now we said talk about iterator, and we say iterator is like the foundation of writing functional programs. For instance, when we look at our list, when we say for I in the list items, print I is now an iterator that we have created to loop through each of the items on the list. Now a generator is a function that returns an iterator. If you have watched your pre-recorded videos, this won't go over your head as much. In a lot of apps that you will build in life, for those of you that will go on to actually be a software engineer, you will prefer to use generators over just having to return a value. You want to yield a value. Every time you see the yield statement, what you have is a generator. A generator function is a function that will return an iterator. The iterator returns a stream of values. When we call a function, local variables are created and destroyed when it meets a return statement. And the value is returned to the caller. So we understand how a function is. We create a function, we end it with a return statement, returns a value to the user. But generators can resume a function for where it left off, like for normal function call, it is destroyed after the return statement. It returns the value to the user. It is destroyed. You can't continue. You have to call the function again. But when you use generator, you can resume a function from where it left off. So generator are resumable functions. That's just the short way to say it. So they're easy to implement. Why we use them most of the time is that they're memory efficient. And you can also be used to represent an infinite stream of data, since they cannot be stored in memory. I was creating a network application. When you do network programming in Python, generators will come in handy, where you are creating endpoints that is going to hit or scan servers and devices on the internet. You cannot save download all these values. You want it to be able to return an infinite stream of data, but not store it in memory, and always give you the next value as you want it. Generators will produce one iterator at a time. So let's look at an example of a generator function. This function we are going to create, we want to create a function that will return odd numbers between 0 and 50. We want to ask for it to give it to us. Let's create a generator function. You say def generator function. You can give it any name you want. So say def generator function, and you want to say for I in range, you say between 1 to 50. So let's say for I in range 50, we want to say, so we want to return odd numbers between 0 and 50. So whenever we want odd and even numbers, we use the modulo operator, because we know that anything that has a remainder is an odd number, and anything that does not have a remainder is when divided by 2 is an even number. So we want to use the conditional statement to say if I modulo 2 is equal to 0, yield I. So we use yield, we don't use return for generators. So what we say, that generator resumes a function from where it left off. Okay? What it returns is the iterator. It does not store a memory or a stream of value. So let's create a variable called y. And we say y is equal to, we call the generator function. So we want to now say, let's print next y to see, to tell you what the next value is in the stream whenever you print it. So it's 0. And when we print next y again, you'll see it's going to be 2. So it just stores the iterator. So 0, 2 just gives you the next as you need it, as you call it. It's not going to store anything in memory for you. We can say we want to print or to say for x in y, and we say we want to print x like this, and now we'll get the values held printed, all the odd numbers between 0 and 50. We have done this using a generator function. This is more memory efficient. When we come to say we want to optimize our system, these are the kind of functions we create. Instead of creating just a normal function that returns something, we want to use a generator function that uses yield. When we say yield, it just yield. When you see a yield statement, it is a generator. So it returns an iterator, so you can use next. Iterators, next iterator, you always get the next in the list. Okay? So this is just the basic concept of generator. So you can actually practice by converting your functions to generator and trying to get the next of it to see that it just stores the iterator. When you call next, it just gives you what the next value is, not storing it in memory. You can resume your function at any time because it does not return a statement to the caller and destroy the local variable that has been created. Is it clear?
Please.
It's very clear.
Yeah, somebody.
Please, I want to know the function name. Will always be generator.
Oh no,
Oh, yes.
the any name of your function. I just gave you generator function, just a hypothetical name. So I can put this like, say the function is def even numbers. Any name you want for your function.
All right, thank you.
All right, so these are the topics that I saw have not been discussed with all the topics we have learned so far. And now let's look at Python framework. We're going to look at the Flask framework. I don't like frameworks. I don't use frameworks, but a lot of people want to know what frameworks are. in Python, the most lightweight framework you can use that gives you the flexibility of really working around the boundaries of the framework is Flask. Fast API is also one. If you do API development, it will be a course that we'll do later in the year. But for now, let's look at Flask. Now, Flask is a flexible Python framework based on something we call WSGI, which is the Web Server Gateway Interface. And it uses something we call the Jinja 2 template engine. Before you use Flask, you must have installed Python 3. So you have to have Python 3 so far in this course. Now, let me just show you the basic way. I think this is week 21 for batch A, when you want to develop your apps with Flask. Now, from week 21, the last 9 weeks of your course for batch A is going to be a bumpy ride, so you don't want to fall behind. Now, I've done between week 21 and week 25, I have done 3 different ways of doing the same thing, and I'll show you the best way of doing everything. We have the command line that we have learned to use. We want to always change directory to the directory we want to store everything that we are doing. Now, we're in a directory called this. I don't want to be in this directory, so I'll go out of it. I want to just go to my root directory here, and I'm in the root, and I want to go to my desktop to make it easy for me to get the folder. Now I'm in my desktop. I have changed directory to my desktop, and for me to start using Flask, I have to install Flask. And you don't want to do any installation of libraries or anything on your general system. You always want to have a virtual environment, and you want to do your installation in your virtual environment, so that when you have 2 apps, the dependencies of one app is not going to make the other app not work properly. You don't want to just mess up your entire system. We use virtual environments to hold all the binaries, the libraries, and interpreters that needed to support a particular project. So outside of the project, those installations do not exist. The first thing we do is navigate to the directory where we want to build our project, and then we create a new folder in that directory that holds all of the files and things for the project. So we want to say make directory. Let's say we want to create an app called, let's say banking, for instance. So I'll just make a folder called banking. So to create a new folder, we'll use make directory mkdir and then the name of the folder. This will be created there. And when we change directory to the banking, we are now in the banking folder that I just created. I can come here to say I want to add that folder here to workspace. It was on my desktop and it's called banking. Now I have my banking folder here and I want to work with this. There's nothing in this folder. I want to use Flask framework to build this app that I want to build. I have made the directory. I have seeded into the directory. I'm now in a directory. The next thing you want to do is you must create a virtual environment. Now, because we are all using Visual Studio Code, our terminal here is uniform. If you are using different command line interface, then what you use for Mac and Linux is different from what you use with Windows. But for here, we can run the same command. So we're creating a virtual environment by using Python 3, env, and then the name of our virtual environment. I like using the name .venv. It's just a convention. You can name your virtual environment anything you want. It mustn't be .venv, but that's the name I want to give mine. Okay, so this is the name of my virtual environment. The syntax is Python 3. I use the m flag, venv, and then .venv or whatever name you want your virtual environment to hold. So you do this. If all is well, you should check here to see that you have a .venv created here. It has been include lib and this here. So you have your virtual environment. Once you create your virtual environment, you must activate it. Do not forget, on every new day you come to this your app, you must activate your environment before any installation. To activate the environment, you write the environment name .venv, which is the name of the environment I have, .venv. Whatever name you have, if you have named your environment my environment, you just write my environment without the dot there, /bin/activate. Now this might result in a permission error. Let's see it. that will have permission denied. If you have permission denied, just put a dot. Put a dot first, a space, and then .bend, and then to stop that permission denied. Once it's activated, you'll find the name of your environment in parentheses here beside it. Once you have activated this, it is time for you to install Flask. Now, when you install Python, pip is a package manager for Python that comes automatically installed with Python. So we do pip install Flask. Now, for those of you in course 3, we use Poetry to manage dependencies, and we will not pip install, but we'll put everything in our Poetry dependencies and to automatically install. For now, let's just do the basics, and then those in course 3 do the advanced. So I'll do pip install Flask. Now, make sure your environment is activated before you start installing stuff, so it doesn't install on your global system. So do this, and everything is installed. Now you see, because pip has a new release, it will tell you to update, run pip install, upgrade pip. You can just copy that code and put it and upgrade our version of pip. So this is how we install Flask. Okay. We have different methods we call HTTP methods. And because anything I do going forward is going to confuse you, we will stop at this installation and go into looking at all of the prerequisites for this course, which are HTML and CSS that you will need to understand every other thing we're going to discuss going forward. Now, for those of you in batch A, this week's upload contains your introduction to Flask or app development with Flask that gives you how to install Flask, how to run Flask, and the HTTP methods, and then it also gives you introduction to HTML and CSS. Now for this live class, I'll hand over to Edmond to give you a rundown or a crash course of the introduction to HTML and CSS that we will use in our template development when we look at Ginger templates next week. So Edmond, are you ready?
Yes, ma'am.
Okay, so I'm going to stop share and I will hand over to Edmond.
Yeah. Okay, I'm going to share my screen now, so I can start. All right. Welcome everyone. My name is Edmond Kaboy, and I will be taking the tutorial for HTML. So, HTML. Specifically, HTML5 is the latest version of HTML, and that's what we'll be using for our development. Now, I have here, I'm going to hide this. I have here my directory that I'll be using to create the HTML file. So I believe by now we know what directories are. So this folder is my project directory. And in here, I'm going to create a file. Now, just like we create files for Python, for those who have already started Python, we create files too for HTML, and the difference between them are the extensions. So for us to tell if a file or a document is in HTML or Python or CSS, which we'll also look at, is the extension. So I've created a file here named index.html. Now, without the HTML extension, the browser will not be able to read this document or file as a HTML document. Now, I said we're going to look at HTML, and we are looking at HTML5 specifically, HTML5 specifically, which is the latest version of HTML. And it's the standard language for creating web pages. So understanding the basic structure of an HTML5 document is essential for web development generally. Now, we might not be creating web pages for our backend development, but just like the question that was asked, how do we connect, or when do we connect the backend to the front end? So you need to understand how the front end works. That's why it's a prerequisite course for this particular course. So we need to understand how the front end works. So this will be the basic structure of HTML5, and we're going to look at CSS as well. Now, to start working with our HTML file, we start with the doc type declaration. And doc type declaration is written as this: a lesser than sign, an exclamation mark, and the name doc type. So what does the doc type entails here is that the doc type tells the browser that the document is an HTML5 document. And next, we want to start with the HTML element itself, which is also written with a less than sign and the name HTML. Now I'm going to explain what these texts here are about. So we have the less than sign with the name HTML, and this letter here, this word here, lang, which is known as an attribute. So in HTML, we have what we call tags. Now, a tag is where we write the different elements that we can find in HTML. Now, we're going to hear this often. We're going to be hearing lots of tags or elements. So you want to take notes of the elements, and the tag is basically what we have here as this syntax, which is the less than sign and a greater than sign with the name of the element inside. Now, some tags or some elements do have open tags and close tags, while some are known as void tags because they do not have a close tag. Now, what a close tag is the close tag here, for example, is the less than sign with a forward slash followed by the name of the element which we have opened here, and we know this as the open tag, and this is the close tag. Now, the forward slash here signifies the end or the close tag for this element. So the HTML document is going to be written, every element is going to be written within the start and the end of the HTML tag. Now, this is where we are going to create content, create layouts, and everything we see on the web page. Now, in this element, which is the HTML element, we have two sections. One section is called the head element, and the other section is called the body element. So I'm going to make this easy for us to understand using the human anatomy. So let's take the human body for an example. So we have the head and we have the body. Now, we usually look at what we wear when we go out, and we mostly have outfits for the body. Yes, we do have for the head as well, but let's just look at it this way. So we have outfit for the body, and we have different color, different type of outfits that we wear for just for people to see or maybe like a fashion that we're trying to show. So everything we do for our body is to are easily seen outside, but the things we think about, the thoughts we have in our head are not seen. So it's usually what we think about that we mostly act, and that's when people see, okay, this person may have thought about this. So that's something similar to what we have for the HTML document. So first, we're going to look at the head, which is where we have different metadata that are not seen on the web page. but they pass meaning. So I'm going to write this first, which is head. And then the head element has a close element as well. It has a close tag. So I'm going to include a close tag here. And in the head element is where we have the metadata that we use on the web page. So I'm going to also explain what this attributes means too. So now, usually we have attributes in the open tags of elements. So the attributes here is for the attribute here for which is lang and has the value of an. So this wraps all the content on the entire page, and the lang attribute specifies the language of the document. So the value here, which is en, signifies for English. So which means that whatever I'm going to do on this document will all be in English and will be read as English. When the user is making use of a screen reader, it's going to be read in English. Now, there are other values you can specify for your lang attributes. You could, if you're writing in French, you use fr and so on. Now, for the head, I'm going to write one of the meta tags, which is written as meta. And there are several attributes for these meta tags. And I'm going to write this one here and explain. Now, the meta tags are void elements. So remember, void elements are the elements that do not have a close tag. And the normal other elements are elements that have close tags, which is, for example, we have the HTML open tag and close tag. We have the head element with an open tag and a close tag. Now, for the meta elements, they do not have close tags, and they give the browser some extra informations. So, for example, here we're going to look at this. So I'm just going to give some more elements, and I'm going to explain what they do here. So now, like I said, the head element contains meta informations about the document. The title, and we can as well have links to a style sheet or a script if we're using a JavaScript, or we want to, I'm also going to look at that for CSS, for using a CSS external style sheet. So we
Sorry, Edmond, it seems you are breaking up.
Oh, okay. Is it better now?
Yes, it's clear.
Okay, all right. Okay, so I was saying that we are going to look at CSS, and that's where we'll see how the link tag works. So for now, we can focus on these meta tags. Now, we have the char sets, just like it was explained for MySQL. The character set here is for the same purpose. So it gives us the alphabetical character set for the document. Now, we also have another element in the HTML element. This is for the head, and now let's look at the element for the body. So the body is also written as body. And like I said, in the body element is where we have the contents that are seen on the web page. So we have several elements that we use to display content on the web page. We have elements for text, elements for images, and so on. Now we have elements for headings for when we write text on the web page. We have elements for headings. So I will come back to these elements we have on the head, but I just want us to see the elements we have first in the HTML element itself before looking at the sub-elements. So I'm just going to use a heading here. And we write headings with the H1 tag. So here, the H1 tag is for main headings. So just like we have for our Word documents, we have main headings, we have subheadings, and so on. So when we want to write main headings on the web page, we use the H1 element. And I'm going to write something here. Say, hello. And just like the Word document, we have paragraphs, and so we have for the HTML document. And to write paragraphs, we write them in the P element, written as P. So I'm just going to make use of the shortcode here. So the P element is for paragraphs. Now I'm going to save this so we see example of how this displays on the web page. So I have split my screen, and this document has been opened on my web page. So for us to see the output of what we're doing here. Now for the heading, we gave hello as our main heading. That's why it's displayed big and bold, because we use H1 for main headings. And I'm also going to show you how we write subheadings as well. And the P tag is for paragraphs for the text on the body, and we use the P element for that. All right, so now the complete HTML5 document is basically has these elements to make up for the document. So we have the doc type declaration that tells the type of document, that it's a HTML5 document, and then the HTML elements, which we use to write all elements that are for this HTML document. And then we have the head element, where we have the metadata, and then we have the body element that gives us, that we use to output content to the page, to the web page for users to see. So let's go back to the head element and look at the different meta tags that we can have on the head element. So the head element contains meta information about the HTML document, and this information is not displayed on the web page, but is used by the browsers and search engines as well. So let's look at the first meta tag we have here, which is for the meta chassis. Now, this specifies the character encoding for the document, ensuring that the text is displayed correctly. And next we have the title, and the title sets the title of the web page, which displays or appears in the browser's title bar. So for example, I have given here that the name of this document or this page is my first web page, right? Now, at the top of the bar here, you can see the title as given here with the title elements in the head area. So if I change this title, say we have a different type of name for a different name for the page, it's also going to change here as well. So let's look at another meta tag. Now we have a meta tag for description. So I'm going to write that here. Autocorrect. Okay, so I'm going to fix this too. Now, the name here is an attribute. Remember, we use attributes to give more meaning to, or to pass more meaning to an element. So I'm going to complete this meta tag. We also have for content. All right, so now this meta tag we have here, I'm going to close this, is for providing short description for the page. So this is mostly used by search engines. So when we need to give, when we need to give more description, we need to give description to a web page or a web browser page. For example, when you search for this, let's say we have a domain and you have to search for something that is related to this website or this page, and we have that on the description. So the search engines will look out for these keywords, the keywords that are in this description that the user has searched for. So, and this as well provides just short description for the page as well. Then we also have other meta tags. Let's look at the link. I'm going to write this below, since we'll be looking at the style sheet. So the link tag is for connecting to a style sheet or an external script. So we can use this to reference a style sheet. Now the style sheet is we're going to look at that majorly after now, but what the style sheet is this cascading style sheet. That's the CSS that we use to design the page. So like we see here, the texts are displaying just plainly without any style, without any stylish fonts or colors. So how do we design this text? We use the CSS for that as well. There are several uses we can do with the CSS, but that's just an example. So we can also have a script tag here in this head area. And the script element is for linking to an external JavaScript file. So let's say we have a JavaScript on our directory here, and we want to reference to the JavaScript file. So we do that from the script tag here as well. Now, for the body elements, the main heading here that we've already looked at is the H1. So we have other headings. We have subheadings such as H2. For example, I'm going to save this and refresh the page. So we see here how this displays. We see that the main heading is quite bigger than the subheading. So obviously we can tell that the main heading here is hello, and the subheading here is the smaller text below it, which is still in bold and different from the paragraph. So we can as well have more subheadings, but we only have 6 elements for headings, and they are in the order to less subheadings. So we can have from H1 to H6 for the different subheadings. So let's say we have a H3 here. And I'm just going to use one text for all. And a H4. H5. And a H6. I'm going to save this. Now it stops at 6, so we see the difference between the headings. Now you can see that they are all in bold, but different text size to tell which is the main and which are the subheadings. So this can give us more importance to the heading. So you tell which one has more importance and which has less importance, but still important because it's a heading. All right, so that's for the headings, and the P tag is for paragraphs. Now we also have other elements. We have elements that we use to reference other websites, an external website. Let's say you want to direct a user to another website. We have elements for that. We have other text elements. We have elements to modify text like we do for our Word documents. So let's say I want to make a text bold, or I want to make a text italic, just like the formatting we have for our Word documents. We can as well do that here. So if I want to make this text bold, we use the elements called P, and it's in the tag just like every other element. And in between the start and end of the B element, you can include the word that you want to make bold. So if I put the word first here and I save this, when I refresh the page, we're going to have the text displayed in a bold text. So there are several text formatting elements that we have, and then there are also other elements we have for different content purposes. So since we're just looking at the basic today, we're not going to go into those complex elements, but majorly we use the text always. So especially when we are connecting to our forms, when developing our backend database, and we want to connect to the forms. So you're going to see elements like this. We're also going to see elements for forms in particular, how we can create a form on the web page. We're also going to make use of elements like that. And those are all the elements we have in the body elements of the HTML documents, because those elements output content to the web page. So any elements that does not output elements to the web page, most of them are usually, there are other elements that you can't see, but they help for you to modify your content. Now, there are some elements that does not display on the web page unless you give a particular condition to it. So, but the idea of these elements is that they help you, or they make it easy for you to structure elements on the web page. Now, we've seen the type of elements we have here. They do not display on the web page, but they give meaning to the documents itself. Now, let's look at CSS. Now, like I said, the CSS, or which is known as Cascading Style Sheet, is what we use to design the web page. So just like we created this file for the HTML document, we do create the CSS file as an external file, or we could decide to include the style. Now, the style has, just like the HTML document has elements and attributes that makes these elements have more meaning. For example, we're going to look at the way to include a style inside the HTML document. Now, there are three ways we can do this. We can as well include it to a specific element in the opening tag of the element, or we can have it here, as explained, in the head area of the documents. Now, we call when we apply the style directly to the element, we call it inline style. So when we apply it on the head area, so let's look at that here. So when we want to apply the style in the HTML document, the name of the style of the CSS elements is called style. So this is the name of the elements, and here we can give the properties for the elements that we want to apply the styles to. So, for example, like I said, we have elements in the HTML document. For the CSS, we have properties for the different elements. Now, I'm going to create a file here, and I'm going to call this main, or I'm just going to call this style. Now, like we named the index file HTML to signify that it's a HTML document, we also have to give the extension CSS to the file to specify that this is a style sheet. Now, we don't write the elements like we do here in the HTML document. We write them differently in the style sheet. So let's first of all look at the inline style. So we see how to specify where the style would be displayed. So let's say we want to add a style to this paragraph. So now we have the paragraph displayed as a plain text, and we now want to include a color. Let's say we want to make the whole text have a unique color. Now, this can be done on any of the text elements we have here. So I just want to use the paragraph, for example. Now, how do we include a style? Just like we have the style elements, here in the opening tags of the elements, what we have are attributes, like we do here, which are for the meta tag. So we're going to use an attribute called style for this, followed by the equal sign, and in a pair of quotes, we're going to give the style. So now the style we want to include here is for color. So there are different properties. So these are called properties. When you want to add something to modify the elements, to make the elements display differently from the default look, or to behave differently, we apply properties to them. So the property here that I want to add to this paragraph is known as color. And what do I want to do with color? I want to change the color of this paragraph. Now, note that I'm doing this in the P element, so which means that whatever I do here is going to affect the paragraph itself. So I want to give a color. So let's say I want the color to be red. So I'm going to type the red color here, followed by the semicolon, and I'll save this and refresh my page, and we have the color displayed as red. So this is the way to apply a style inline. Remember, it was done in the, I'm going to close this. It was done inside the opening tag of the element, and the closing tag still remains closed at where it is. So we do not write anything in the close tag. We only apply these attributes and styles to the opening tag of the element. And remember, we still have an element for bold inside this paragraph, and it does not affect the style as well. So you can see it's just like the way we use our Word documents. We can as well do the same here in our HTML document. So we can also include these styles, this same style, to any elements, any text elements we have here. But let's try the embedded way of applying style to the web page. So let's say we want to include a color we want to add a color to the heading. So let's say the H6, or okay, well, let's use the H3. Yeah. So I want to add the color to the H3. Now, remember I said that we don't write the same way we don't write the elements the same way we do in the style sheet. So what we have here is like a mini window for the style sheet in the head area. That's if we don't want to use the external style sheet. So this style element helps us to be able to make use or write or use the CSS in the HTML documents, but differently from the inline way of applying the style. So let's say we want to apply style to H3. Now, instead of writing the H3 as it is as a tag, we just type the H3, and in a pair of curly braces, we apply the styles or the properties that we want to give for the H3. So now let's say we just want the color of the H3. So just like we did for the P tag, let's apply a style using the color property. So that several properties that we can apply to a text. So it depends on the elements. We have properties for text, we have properties for images, we have properties for forms and tables and so on. So it's just the way we have with the Word documents, the way we can design our Word document sheets. For example, when we apply a style, like we apply colors to text, we create tables, make the color of the table as a desired color as we want. We can as well do that here using these style sheets. So now I want to apply a color. So I'll say color and followed by a colon. Now I want to use a different color. Let's use blue. And we always close the line with a semicolon. I'm going to save this and refresh the page. Now, the H3 in particular, since we've specified that we want the H3 color to be blue, has taken effect on the web page. Now, we can as well call on any of the elements. We could say we want the P or the H1 or H2 or H4, and this is how we apply the styles. Now, let's look at how to use the external style sheet. Now, in the external style sheet, just like we have done in the embedded style sheet, we also write the styles or the properties the same way. So we do not write the elements like we do in the HTML documents using the tags. Instead, we just call the elements using the name of the elements. So yeah, let's do for the H1. And in a pair of curly brace, we give the properties. So for this, we are going to change the color. And let's use purple. Okay, so I'm going to save this. Now, if I save this and refresh my page, the color would not take any effect to our heading, the H1 heading. Why? Because we may have the link tag to reference our external style sheet, but for us to be able to apply, or for us to be able to connect this document to the style sheet and make sure that the styles or the properties we give in the style sheets take effect to the elements we are applying it to, we have to reference the style sheet properly. Now, we may have had different exercise in the backend course where we look at, for those who are already, who have done the course one already. So we've seen how this is done, but for those who haven't, when we reference a file, we usually do this in the link tag. We usually do it in the href attributes. And when we want to reference a file, we may have different structure in our project directory. Here, I just have 2 files. I don't have any subfolders. Now, I'm going to show you an example when we have a subfolder for our style sheets and when we don't have a subfolder for the style sheet. So let's say I want to reference this style sheet. Now, I have these 2 files in the working directory, my project directory named tutorials. Now, I want to reference the style sheet itself. So all I have to do is call the name of the file in the href. So since I don't have this in any other folder, it's currently in the root folder, I only have to call the name directly and say style.css. And if I save this and reference the page, we have the color that we've given to the H1 in the style sheet taking effect on the heading, the H1 on the web page as well. So now let's say we have this style sheet in a folder, still inside our project folder. So I'm going to add a folder here, and I'll call this folder my CSS folder. And I'm going to create the style sheets inside. Let's call this main.css. So you can give any name to your style sheets. I want this to be main.css. I know I already have a style.css. I could delete this or leave it there, but we want to look at how to reference a style sheet from a folder. Now, I would apply a style to the H2. And this time, let's use the color to keep everything consistent. So let's use a color, and I'm going to select from my suggested colors. Let's use Aqua. Now I'll save this. And remember, we have to make sure that we reference the file, else the properties or the style we've created inside the style sheets would not take effect to the elements that we want to apply the style to. Now, all I have to do is I have the style sheet inside the main folder, the CSS folder, and the CSS folder is inside the tutorial project directory. Now, the first thing you want to do is you always want to take note of where you currently are on your project directory. Before you reference a file, you always want to take note of where you are. Now, this will help you guide you to where or how you're going to locate the file you want to reference. Now, I am currently in the index.html, and the index.html is in the root directory. Sometimes you may have the page or the file inside a folder, and you have to come out from that folder to reference a file in another folder. So I'm currently in the root directory, so I do not need to come out from a folder. What do I have to do is I want to go into the CSS folder, and I want to reference this file called main.css. Now, all I have to do is mention the folder first, and the name of the folder is CSS. And with a /, I have entered the folder, and I want to locate the file called main.css inside the folder. So I would type the name main.css. Now save this. Now, once I have successfully referenced it, I should have the style I have applied to the H2. Now you see the style.css file is not referenced anymore. So that's why we no longer have the H1, which we have previously applied a color to. Now it's no longer taking the effects anymore because we are only referencing the main.css in our href. So you could have multiple style. If I also try to include the style called, so I'm going to use another link tag here. So we want to look at having two styles applied. So, and the name of this is called style.css. So the referencing is that we just call it, since we're currently on the same directory, we do not need to come out or enter into another folder. So I just reference the file directly, which is called style.css. And if I save this and refresh my page, I have the property for the color being applied to the heading again, because I have referenced both of the files. But the referencing here are different because one is in a folder and one is not in a folder. Now, what if we are currently in a folder and we want to reference any of these files from a folder? So I'm going to create another folder here, and I'll call this pages. Now this folder is expected to have all the web pages for, let's say I'm building a website. So this folder is expected to have all the web pages for this website. And if I create a file here and say, let's say we'll call this about page. So remember, you have to give the extension, which is .html. And now you can see for my working directory, I have two folders. And in the second folder called pages, I have a file called about. So I'm going to make use of this same structure. I'm just going to copy all this because of time. Now I want to change some things here. So we're currently in the about, and I'm going to change the title because the name of this page now is for this page is for the about page. So I'm going to save this, and we haven't opened this page yet, but I just want to make sure that it has different content. So I'll take this out. And I'll call this heading about and save this. So let me open this on the browser. Now I have opened this page, and I currently have just two contents, the heading, about, and the same paragraph. This is my first web page. Now, the reason why the style for this paragraph remains the same is because I still have the style, inline style attributes here, which makes sure that the color is red. So I want to reference an external style sheet from this page. Now, remember, before you reference a file, you always want to take note of where you are. So it will guide you to understanding how you can locate a file or to navigate to a particular file you want to reference. So I'm currently inside the pages folder, and I am in the about.html. So I'm going to take out every other tab here. So I want to reference the file main.css. And in the main.css, I'm going to change this style to h1, since I only have a h1 element inside the about page. So I want to reference the main.css. I want to, first of all, look at where I am. I'm currently in the about, and the about is in the pages folder. So we have to come out from the pages folder first. So in the href, I would use a double dot and a forward slash. So just like we do when we are trying to come out from a folder in the terminal, for those who have seen this on Python. So we use the double dots and the forward slash to come out from a folder. And this means I am currently out of the pages folder. So what do I want to do next? I want to look for the main.css file, which is inside the CSS folder. So now, after coming out from the pages folder, I would mention the name of the folder I want to navigate to, which is called CSS. So I'll type it here, CSS. And now with the forward slash, I am currently in the CSS folder. And next I want to reference, so there may be other files in the CSS folder, but I want specifically the main.css. So I'm going to type the name, main, and remember to add the extension .css. Now save this and refresh my page. And now the style we have in the main.css for the h1 has taken effect on our h1 in the about page. So this is how the CSS works and how we reference CSS on the HTML documents. And as well, this is the base structure of a HTML document. We have the head, we have the body, the head for metadata, and the body for contents or elements that we use to output context to the web page. Right, so I think this should be enough for the introduction. So if you have any questions, please feel free to ask before we round up. All right, so if there are no questions, always remember to reach out to us from the WhatsApp group. If you have any challenges, feel free to ask from the WhatsApp group. So reach out to any of the admins and we'll get to you. All right, so that's all.